I'm going to do M1R here, and I'm going to do it using what's called the debugger. So this is a reading problem where you're supposed to trace through this code. And so here's main. Let's see if we can get it all on the screen. Main makes 2 points this time, and it prints their X and Y's, which you would expect would print 10, 20, 30, 40. And then it calls blah, sending those points here. And then we get these arrow effects because this 1 point equal sign this point, and this thing, this another point, equal sign that point. So we now have arrows from the names here to the objects defined there. And I want to demonstrate that by running this in the debugger. So let's see here. I'm going to create what's called a breakpoint. So I just clicked right there. And that will cause, when I run this in the debugger, now let's see if I can make things readable here. I'm going to make that there. I'm going to, I'll leave that there. I'm not sure whether that's going to be helpful or not. So where we are right now is we're right down here ready to run that line of code, main. We've hit the break point. The debugger is a handy way to debug your programs, and absolutely you can and should use it if you want. It's just that print achieves much of the goals, and it's just overkill for this course. In CSSE 220, the follow-up, you certainly would use a debugger. Anyhow, this step into's the only one that we got to worry about. That just means go to the next line of code. So when I click on that, the code came up here into main, and it's ready to do. It has not yet done, but ready to do line 25. When we hit that and run line 25, so that's what this is going to do, it's doing the right-hand side. So it goes up here into a init, and it sets, let's see here, we have X, which is this X here, and Y, which is this Y, set equal to 10 and 20 respectively. Self is set to a point object, a place in memory. Currently, there's nothing at that place in memory. It's just some memory reserved. Continuing a little bit further, that caused self.x to be X. So inside self, there was a .x, and it refers to the same 10. These two 10s are really the same. Megan, back to you. Whenever you have references to primitive things like numbers, things that don't have an inside, the arrows will always behave as if they, in the way that you would expect. You don't see these unanticipated things with what's called primitive type objects that have no inside. But anyhow, there's self.x. It's referring to 10, and there's the place in memory. And then when I click the thing here, self.y is going to be set to 20. So when I click here, now it just came back to main, and so all these names just went away, but it would have set self-y to 20. The data is still there, the names are gone. I want to go a teeny bit further, and then I'll let those of you that wish abandon ship. When we hit this with the right-hand side happens, so we're going to come back into the init, because that's what the name of the class causes to happen. So we come back into init, we're there a second time. It allocates a new set of storage. It makes, let's see, this is here we are. Sorry, I've lost track of whether I've done this line. Yeah, we've done point 1. We're still in main. Point 1 refers to that storage. Notice that it ends with 880. It has a .x and a .y. There are 10 and 20. And then when I hit the arrow, now we go into init. Previously, we were just doing the left side of line 25. So now we have self again at a different place in memory. The other one ended in 880 or something like that. This ends in 190. Self refers to that storage. X and Y are 30 and 40 this time. As we continue, self's X becomes 30, and self's Y becomes 40. And if we finish off this statement with another click, we now have point 1 and point 2. Notice how they were referring to different places in memory. And so point 1 has some values and point 2 has some values. The punchline is coming up right now. So if you've tuned out, tune back in. Oh, I see. We've got to get through some prints. Let's try to get through those. And now we're going to call blah. So we've just come down to blah. Blah has two other names, one point and another point. Remember that 880? 1 point refers to that same place in memory. 1 point equal sign point 1. So what was called point 1 up here in main's namespace referred to a place in memory that ends with a, if I remember my numbers right, yes, 880. 1 point refers to that same place in memory. And so 1 point already has the 10 and 20, just like you'd expect. 1 point equal sign point 1. Point 1 was 1020. Well, 1 point is 1020. But what might be unexpected is when we then continue and do this next line of code, 1 point x equal 111. Well, we certainly expect 1 point's x to be 111. But that thing at place 880, which up in main is called point 1, when we get back to there, we're going to see that it picked up that change to the 111. I'm going to go a little bit further, but if this is all over your head here, feel free to just abandon ship here. We're going to repeat this many times over the next, 8 sessions or so. But this is our first introduction to the way that assignment really works. I'm going to go a teeny bit further, and then I'll take questions. And again, feel free to abandon and just start working on the session one-on-one if this is not making any sense to you. I just want to get as far as this here where another point comes into existence. Third point equal 1 point makes a third point referring to the same place in memory that 1 point equals to. Again, what equal sign means is draw an arrow from the object on the left to the value on the right. 1 point's value is this place in memory. Third point's value is this place in memory. But then when we do 1 point equal a new point, we come back up there to main, we have the self, we make a self, and now we have 1 point. Let's see, we haven't quite finished it. We've done the right-hand side, but we haven't done the left-hand side. 1 point now refers to a different place in memory. What questions does anybody have about anything?